So, you're all using oscilloscopes, you've all got lovely waves on the screen and everything, but kind of actually what does it mean? Your basic premise of your oscilloscope is really all it's doing is plotting a graph. You've got a plot of time versus amplitude. So in other words, this is in the time domain. We live in the time domain. There are other domains. There's the frequency domain. We don't live in the frequency domain, but we can engage with it to a certain extent. But I think you all know that we can't rewind time, because otherwise we will be 21 years old for the rest of our lives. So time passes, we've got no control over it whatsoever, but on a scope, what we can do is we can make adjustments to the time domain in such a way that we can set this to pretty much anything we want. So we can make this 1 second intervals, or we can make it thousandth of a second, millionth of a second. These scopes will see very, very fast, up to about 20 megahertz, reasonably those ones. And it's all under our control. So we can control the amplitude, because we're controlling the gain. So we can control the amplitude, and we can control the time base. So two main controls on a scope: amplitude, time base. And if you get those set right, then you're looking at a waveform that actually makes sense. It looks like, well, usually a sine wave, but not exclusively. But you end up with a wave that you can actually see and take measurements on, and all the rest of the magic that goes with it. There's another concept which is less well known for many students. We actually turn things slightly on their head, and we say, let's look at frequency. This is still amplitude of a kind, but it's not amplitude as you might think of it normally. Let's have a look at things in frequency. So, if I put, say for example, if this is 1 kilohertz, and I set these to and so on, I'm going to get myself that sine wave, so I'm going to see that sine wave which is coming out of the signal generator. What do you think? So this is time domain, where we live as humans. The frequency domain. Now, are there people that live in the frequency domain? I wouldn't dismiss it. It's a bit Star Trekky, but I would imagine it is possible that life form can exist inside a frequency domain. As a matter of fact, there is a Star Trek episode where just that happens. But what that means is that past, present and future all happen at the same time and simultaneously, which is a bit difficult to get your head around. But what it means is if I take this 1 kilohertz sine wave here and I plot it on the frequency domain, what do you think it's going to look like? Remember, it's a one sine wave in the time domain. What does it look like in the frequency domain? No. So amplitude, frequency, I put 1 kilohertz into a spectrum analyzer. A line?
A pulse?
A pulse, yes. So what does that look? Just a line? Is it horizontal or vertical?
It's a vertical line.
Vertical line. The gentleman there is correct. So what we have at 1 kilohertz is a line. We always draw them in schematics with an arrow on the top, but you won't get an arrow on the top when you do it inside one of the oscilloscopes. You get a single line, but only if it's pure. if it's got a certain amount of bandwidth, in other words, it's not exactly 1 kilohertz, and some of it's 900, some of it's 1100 or whatever, this trace here starts to get a little bit more like a sausage or something like that. So it starts to get some width to it, but it's still in the frequency domain. One of the massive advantages of the frequency domain is when we look at a sine wave, we might not be able to tell that it's actually got a bit of bandwidth, a bit of impurities in it, as it were. But if we look at it in the frequency domain, we can see all of the components that are there. So if it's 1 kilohertz and 25% of it is 500 hertz, 25% of it is 1.5 kilohertz, we see it all because we can see the shape of that pulse which is there. It becomes less of a pulse and more like a box or a histogram, yeah? Is that making some kind of sense? The time domain, frequency domain. And guess what you can do on these? You can do time domain, you can do frequency domain, and you can also generate the signal on that. So it's a signal generator, it's an oscilloscope, and it's a spectrum analyzer. Okay, so there's real 3 magic things which happen in AC. Okay, do you want to, shall I get that visualizer? And then we'll do a demo of the live scope. So what we're going to do now, we've spoken about these things, and I think most of you know how to do this, but we're still going to do it on the Roden and Schwartz, so we'll project that up onto the screen. But the bit that you probably won't have seen before is the spectrum analyzer, and that's where we're going to have some fun with that. Okay?